From South Bend, Indiana, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
There's a lot of opportunities that have arisen as we started to better understand, well, what can we do with spare parts, right? How can we start leveraging the technology to not only look at kind of those high-value innovations, but those aggregate innovations where we can use laser powder bed fusion, for example, to print pump impellers.
That was John Barnes. John is the founder of Additive Nexus, a consultancy helping heavy industry scale additive manufacturing from pilot to production. John's previous role drove AM initiatives at ExxonMobil's Technical Computing Group, where he helped connect engineering, supply chain, and maintenance to real-world uses of AM. He's also been active around the industry, including standards and digital inventory efforts like API 20S and frameworks for the broader push to make on-demand spare parts trustworthy at scale in the oil and gas space. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials, qualification, or additive manufacturing support when it comes to data management, reach out to the team through our website or via email at info@3degreescompany.com. All right, John, thank you so much for joining the show today. Really excited for the conversation and kind of seeing where we go with it. But to begin, I always like to start from the very beginning for you. So where were you born? Do you remember having a seminal engineering moment that kind of got you down the track that you are today?
So I was born and raised in southern Arizona, southeastern Arizona. My upbringing included a lot of toys from my father that were educational in nature. He bought me a analog computer when I was like 6. It was a little battery powered device. I thought I would try and see if I could power it through the wall socket. That didn't work very well, but I learned a lot from those. Right, I learned a lot about electronics and switching and how those mechanisms work. I've always been interested in kind of the take apart, tinkering kind of aspect of things. I'm very interested in manufacturing because that's kind of the culmination of all that. But yeah, I started in that space when I was young. I couldn't say I was really focused on engineering. I was focused on being a kid, playing outside, doing things I shouldn't do. But as time progressed, in high school, I started taking some computer-aided design and some drafting classes and really getting into, how do we actually design for industry, whether that's, for mechanical applications or how do we do it for architecture. In college, when I initially went to college, I was in a pre-engineering course that involved early computer-aided drafting, AutoCAD version 12 with a digitizer and an old professor who helped us learn to draw on the board. So we had boards with rulers and learning how to do early pen work. But one of my early co-op jobs I had was actually at a city government where my job was to edit some of the plat maps. So I got to take out a electrically powered eraser and erase roads and realign them. And so that was a lot of fun. But it helped me to understand kind of the basis of what does mechanical drawing look like? How do we use it and apply it? And how can it be used to better our lives? From there, I got tempted by the dark side and went over to information technology. There was a lot of opportunities in that space in the 1999-2000 timeframe, right around the Y2K issue. I went and got a degree in computer information systems from a local community college. Started working as an MIS professional in Central Arizona in the Phoenix area. Supporting servers and desktops and software. At some point, I realized that, having an associate's degree wasn't enough. Went back to college, went to Arizona State, got an operations management degree. At which point, I came across my previous employer, ExxonMobil, and interviewed with them and joined them as I graduated from Arizona State. But as time progressed, right, there was always some tinkering going on. My shops include, so at the current moment, I have 9 printers in here, little desktop printers. My interest in additive manufacturing actually started back in 2011 2011. So in March of 2011, the Raspberry Pi Foundation released the Raspberry Pi. And as a tech nerd at that point in time, I decided I was going to buy one, which I did. And it was early on in the life cycle of those devices. So I bought one, and it was going to be months before I got it. But after I purchased it, I had this fleeting thought of, well, what am I going to do with this thing? Right? I understood desktops and servers and how we manage IT infrastructure, but for this little credit card sized computer, I was like, well, what's the applications? And so I went out and started exploring, and I looked to see what are people looking at using these devices for, and there was a mention of 3D printing. Now, at that point in time, I didn't realize exactly how advanced the technology was. I had seen some television shows that were talking about prototyping. I saw some that looked at stereolithography and how you can produce components using that technology, as well as binder jetting. But I didn't know that there was an aspect of it that was accessible to a guy sitting in his garage, right? I thought, well, these are all industrial machines. There's no way I could touch this. But as I delved into that world and I started looking at, well, what's really out there, I came across the RepRap project, out of the University of Bath. And the RepRap project, that was a very intriguing premise, right? Can I take a printer that can make parts for other printers? Can I print a printer? So, RepRap. And so I dug further into that, came across MakerBot, which was starting to really kind of come into its own in that point in time. That was well beyond my reach. It wasn't tinkery enough. And so I thought, well, I'll just make one of these myself. And so my wife would tell you I disappeared for about 2 months as I sourced all these parts, figured out how I was going to use them. In the early days, you actually would have to find somebody with a 3D printer to print you parts for your 3D printer. And I was in Houston at that point in time. I didn't know that in Houston there was a community that worked with these machines, but I reached out to a guy in California, and he printed me parts. And so I manufactured myself a Mendel Max in my office, and put that together, went through all the learning curves, built the electronics for it, burned through a couple of hot ends. One of my seminal moments after I built it and it was printing for the first time, I went somewhere with my wife, and my son called me up and says, Dad, the hot ends melted off the end. And so at that point in time, I realized, well, maybe there's a little more to this that I need to learn other than just building the machine and try and use it. So from those early moments of really digging into the technology, how it can be used, I got to the point where instead of just printing parts for the printer, which is what I did largely in the beginning, I started to realize that there were some industrial applications, even for the desktop printers, that could be leveraged, right? How do we use that internally? And so in the 2012 and 2013 timeframe, I started pressing some of the internal folks at ExxonMobil on, well, how do we plan to use this? What are some of our applications? And the answer in the beginning was, well, we don't manufacture anything ourselves, right? We use third parties. But there is within most corporations, large corporations, research and development organizations. And they do look at these type of technologies, specifically when they're emerging. And so within ExxonMobil, there was an organization called TechSpring. And what TechSpring was attempting to do was kind of get in front of some of these emerging technologies, looking at the Gartner hype cycle, determining which technologies should be adopted, and then how do we use them. And so that 3D printing was something that came up in the 2013 timeframe. And so there was an internal community of practice that was formed to try and start utilizing the technology. And it reached out to and involved many organizations. It reached out to folks like B&B out of Norway. It reached out to various academia resources. It reached out to folks that were on some of the cutting edge areas of the technology. We talked to EOS. We talked with other companies like SLM Systems. We talked with X1, and we really started I started gaining a much deeper understanding of the technology and how it worked. Now,
how much of this was this most of your day job of doing this, or was it like a small part to start?
In the beginning, it was a small part. So I still sat in the IT organization, but my goal was the TechSpring organization had purchased a MakerBot replicator too, and they had it in a closet. Well, I took it out of the closet and put it on my desk, and I was printing stuff with it all the time. I wanted to delve more deeply into technology, and truth be told, my Mendel Max that I built, it was it was a work in progress, and it was not as polished as a machine that had been manufactured by another. It still worked, but I had a lot of failures on that machine. I got to the point where I was printing one part at a time because I didn't want to waste all my materials and filament on a single part. But what happened was I started looking into some of the news stories that were coming out of organizations like, the 3D print industry or 3dprint.com. There were a bunch of companies that were talking about applications. And I started, internally we had a Yammer feed, and I started posting these in the Yammer feed. Look at this application that's looking at, stochastic lattices, or look at this application where someone has built a turbine nozzle or a turbine blade, or, there was lots of early innovation that was happening. And some of it talked about some of the, ExxonMobil's peers. What were they doing in the space? How were they trying to adopt the technology? And in those early days, I spent about a quarter of my time doing that because I had another job. I was supporting an application for the company, but at one point, the manager of this TechSpring organization said, "Hey, you look like you have an interest in 3D printing. Do you want to come over and work within our organization and start doing that as part of your day job?" And so over time, that morphed from kind of a part-time job to, in about the 2016 or 2017 timeframe, becoming a full-time job because there was enough activity going on that could be justified. So
That's amazing. So what was so TechSpring kind of started as a like multi-location, multi-team, or like multi kind of member group, but like what did you end up coalescing around a vision? Was there a vision ultimately of like, okay, hey, we've seen a lot of this stuff. We've talked to a lot of companies. Where do we want to go? Even though like, hey, like the prevailing thought was like, hey, we don't manufacture anything to start, but what was the balance? Where did you kind of net out as it evolved?
So that's an interesting conversation that we don't manufacture anything common, and so I'll get to that in a minute. So what happened? Well, TechSpring was a technology accelerator, right? It was intended to help the corporation understand what technologies they would use, and then onboard them and kind of spin them off into their own entity, right? Because ultimately, it's fun to play with new technology, but you want to find a business use for it.
Something like they would do that with like AI today or 5 years ago.
They had RFIDs they were playing with. They had, at one point, they came in with this membrane that you could turn on and off. You can make it transparent or opaque. But they were looking at a broad swath of technologies, and this was kind of a grassroots effort. TechSpring, right? They had some centralized staff, but they were very limited in number. And they would go out and they would look at startups and say, what are you doing in this space? Things like drones, right? So in the 2015, 2016 timeframe, a lot of inspections for offshore platforms and things like flares in refineries were done by people. Right? They get in buckets, they go out there and take pictures, they would inspect. And there was a realization that came that we can use these tools to do this. And one, it'll cost a lot less because I'm not having to deploy somebody, and there's a lot less risk, right? If I lose a drone, that's a costly thing, but I didn't lose a person. There's not the safety aspect of it overweighed the cost. And over time, those systems grew more capable, right? They learned from what was going on around them. They developed new capabilities. They started bringing things in like AI, machine learning, doing a lot of image recognition, and they really moved the bar. So if we step back to additive, right, what happened in that space? Well, some of the same things happened, even in ExxonMobil, right? ExxonMobil started looking at, well, how do we use the technology, right? We understand what it is now. We had a good basis between the ASTM F42 7 process families. We had connections with machine manufacturers, OEMs. In some instances, we talked with part OEMs to kind of look at, well, what's the state of the art and how can we use it? And where might we leverage the technology? And so we looked at a range of R&D applications, geometry, materials, to look for enhanced capabilities, kind of look for these kind of big bang applications. And over time, what we learned is that those exist, right? You're really starting to look at design for additive there. You're looking more deeply into the material space, but there's a lot more time consumed in developing those. And in some instances, those R&D projects, even though you learn something, you don't get a commercial product out of the end. So So in the Tech Spring organization, they spun us off. They spun me off. They they hooked me up with my manager at the time, who was our advocate. He was our kind of my mentor. Helped us to develop the capabilities out of our Clinton, New Jersey Technology Center, our lab that the ExxonMobil Research and Engineering had up in that region. And we really started looking at what are the applications that might bring us some, where can we find benefits, right? Because ultimately, a lot of companies develop technology, but they have a hard time scaling it. How do I take it from, it's one thing to print something on a desktop printer, but how do I take it to something industrial scale? And so just for context, it can be hard to visualize, how big some of these chemical processing facilities or some of these upstream or downstream facilities are. But these are, the equipment in these facilities can be massive, right? You're talking, 20, 30 stories on some of these furnaces and heaters. You've got, separators, you got drums. There's a lot of complex, heavy, large equipment. And so in the beginning, things like laser powder bed fusion, for some of those applications, it was too small, right? Mm-hmm. But at the bottom end of that, there's all of these individual components that are part of the support equipment, pumps and filters and compressors, and they all help drive it, and they all have components. And for context, there's a lot of opportunities that have arisen as we started to better understand, well, what can we do with spare parts, right? How can we start leveraging the technology to not only look at kind of those high value innovations, but those aggregate innovations where we can use laser powder bed fusion, for example, to print pump impellers. Well, pump impellers are not an expensive item, but when you look across a fleet or across a series of refineries, you're talking about thousands of them. The challenge is they're not really repeat, right? So I may print a pump impeller once over a 5 or 10 year time period, but if I have thousands of pumps, that means that the potential to do maintenance on those pumps exists across the entire time frame where I might want to do it. So we got interested in spare parts. We realized that there was opportunity there, but we started looking at, well, how do you systematically go through your inventories and go from the point of I've got a broken part to something I can use that can be additively manufactured, and then what are the opportunities? And once again, we learned a lot. One thing I learned is I made that comment early on, ExxonMobil doesn't manufacture anything. Well, that's not 100% true. It is true that for the most part, the company purchases equipment from machine OEMs, from service providers that do, for example, remanufacturing of components. But many of our facilities, especially our fixed facilities, refineries, chemical plants, they have shops. They have machine shops. And there are instances where they'll reproduce a pump shaft, or where they'll go, if there's a need, they will manufacture a part, because downtime is money, right? So some of these pieces of equipment, every day of downtime is millions of dollars. So you need to have a method to rapidly recover those. And so we learned that, right? And then we started learning, well, how do we go through and do this kind of digital inventory concept? So DNV has been working on a digital inventory joint industry project for a number of years, looking at how do I create a digital warehouse? What does that look like, right? What are the standards that I would utilize? What are some of the, how do I dictate something, for example, there's a DNV standard that's called DNV B, or it's RP B205, and it talks about digital inventories, and it talks about digital readiness levels, right? So as we started delving into this, we realized a couple things. One, we couldn't boil the ocean. So large corporations, their stockpiles of spare parts can number in the tens to hundreds of thousands, right? So these parts, and they're spread around the globe. And so you've got all of these individual entities, refineries and chemical plants, or if you're in heavy industry, right, manufacturing sites that have stockpiles of spare parts, because they are concerned that the manufacturer, there's two things they're concerned with. One, they're concerned that the manufacturer that they're utilizing to purchase that part, they may go out of business. So some of these refineries have been in operation for well over 100 years, and the machine OEMs that they worked with originally, they're just not around anymore. Or even if they are, these pieces of equipment are so old, they're still functional, but they're so old that the spare parts are no longer on the shelf. So that provides it provides a challenge, but it also provides an opportunity, right? The challenge is, well, now I've got a series of older components that I might need to replace. Everything from an impeller to a connecting rod to potentially something like a compressor crankcase, right? We're talking from small parts to much larger parts. And I need to be able to, I need to be able to capture those, because I don't know at what point in time I'm going to encounter one of these that has a failure, right? The failure could be, I could wear out a pump impeller due to use in erosive environments. I could break off a bolt mounting on a compressor case that's 70 years old, where my only hope is maybe I can find one in a boneyard somewhere. And so I need to start doing some proactive steps to make sure I have that available in the event that I can't source it. And I also need to start establishing relationships, not only internally, but with third-party contract manufacturers, to make sure that they are capable of producing those parts. So that started us down the road of, well, how do we do this systematically, right? How can a large corporation look through its overall inventory and determine what makes the most sense, right? So what do I chase, and what's the opportunity there? And how do I systematically do it across tens of thousands or hundreds of thousands of parts? And so I think the DNV standard helps us with that some, but there's some footwork required, right? We've got to start looking through our inventories. And many companies have done this. There are many software vendors that are looking at ERP systems, looking for similar parts that can be digitized. But there's always the boots on the ground activity, right? I've figured out what I'm going to digitize. Well, one, I either need to collaborate with the machine OEM and look for mechanisms to digitize that part, or two, the other thing I can do is I can go into my warehouse, and for commodity parts, for things that are no longer protected by IP, I can start digitizing those. But that needs to be systematic. I need to go into my warehouse and start scanning some of those parts, because the way things are working today is kind of in an ad hoc method, right? I've got a component and it breaks. Well, the moment that it's broken, I've lost some key pieces of information. One, I don't know what it looked like originally. So if I had a pump impeller, going back to our poster child, when I retrieve a pump impeller from a piece of equipment that's been worn, it no longer is the original thickness that it was, right? So it's, in some instances, there's holes in it, there's missing veins, there are characteristics that are lost. And so it makes a lot more sense to do that kind of in the front end as a preparatory hedging activity. I'm going to go and capture the part, but I need to be strategic about it, right?
And are you thinking about this only in the context of additive manufacturing? So have you so you're thinking broadly digital. You're not necessarily constraining yourself to stuff that would fit in a shoebox style DMLS build, right? It's much broader than that.
Yeah, and I think that's how we need to think about it, right? So if we step back and look at additive manufacturing, it's a tool. It's a tool in a toolbox. It's like a CNC lathe. It's like a manual lathe. It's like a press brake. It's a tool, right? And what I need at the end of the day, and what companies need, is they need functional spare parts, within a reasonable amount of lead time and a reasonable cost. The method through which they're delivered becomes secondary. Additive can play a role in there, right? Because in many instances, it can be faster than some of the other traditional manufacturing technology, but that's not always the case, right? So digitizing these parts, it has a multitude of benefits, right? If I'm going to CNC a pump impeller, if I have a digital model of it with all of the technical specifications, with tolerance drawing, with the statement of work saying what I need out of this part, and an inspection and test plan for it, I'm golden at that point, because I can use AM to produce it. I can CNC mill it. I can rapid cast it. I've opened up kind of the opportunity to leverage contract manufacturers to help me fill the gap, right? So you're right. It's broadly applicable, and I think as additive manufacturing professionals, we need to look at it that way, right? We need to not constrain ourselves to the single technology. Now, additive can play a role, and in some instances, we need to look at the total cost for components to understand what that is. So we had a use case that is, I think, publicly available. It was looking at a small nozzle, and this nozzle was comprised of 4 different parts. And the process to produce this, it involved machining, of tool steel, it involved assembly, threading, welding, and so the cost of these was actually it wasn't insignificant. they weren't overly costly to produce. But when you start looking at volumes for this was a bin stock item that a site could potentially go through hundreds of thousands of these. Well, now the aggregate cost starts making a difference. So we leverage one of our contract manufacturing partners to look at it differently. I talked a little bit about the like for like replacement, right? A lot of companies are in the stage of they're just taking what they have off the shelf and they're reproducing it, which is okay. We can do that. That's an early stage utilization of both kind of digital inventories and additive manufacturing. But the value comes when we start looking at, well, how might I change this part? And what might that bring to me? So in the instance of that nozzle, there was an effort made to combine those 4 parts into one, which meant it took all the machining to thread these components together. It took away the tack welding to fix them in place. And it helped to actually produce them at a much better cost or price point than they were produced at before. And these were small parts. These were probably about 1.5 inches in diameter and maybe 1.5 inches tall. But when you start looking at some of the larger laser powder bed fusion printers, I can put dozens of these things on there. I can put hundreds of them. And so I can really start leveraging the technology and getting an economy of scale out of it because I've simplified them.
And how much do you think of the cost, as well as like there's the per part cost, you can calculate material usage and machine time and all that, but are we still thinking about it too in terms of the cost for me to justify changing in a piece of equipment, knowing that I may have to do additional testing? If it's 1 part instead of 4, does that reduce testing? Does that increase it because you're using a different process and you have to rely on other data that may not be as longitudinal as maybe a machined part or cast part?
So in this instance, we started simple, right? These were commodity parts that were consumed that were not in a critical service.
Okay.
Right?
So kind of bucket it into that.
Yep.
Yeah.
So what we needed to do is we needed to have some early wins, right? We needed to be able to say, well, and in this instance, an engineer showed up at the specialist desk and set this thing on his desk and said, "Hey, can we make those?" And my original response was, "No, they're commodity parts. They're too small." But that wasn't actually so. Luckily, the engineer that I was working for, the specialist I was working with at the time, he went ahead and sent it off to a contract manufacturer and went through the process of digitizing it to see, well, can we make this better? And so for companies that are starting to adopt the technology, you don't have to start at your most critical part. You could, but you'll spend a lot of time and effort qualifying that part, which is what you should do. But there are a lot of other low-hanging fruit, right? If you think about support equipment, ancillary jigs and fixtures, even talking about things like commodity nozzles, there are opportunities to leverage the technology for that. And the economy of scale, it comes because when we pay for additive manufacturing, we're paying for machine time. So with laser powder bed fusion, if I can put more of those parts on the build plate, my machine time goes up a little bit. But if they're all the same size, all the same height, I'm getting more bang for my buck because I'm able to utilize that machine time more effectively. And in many instances, we found that the material cost was much less of a significant player in that overall question or the overall equation. So if we were able to spread those across a build plate, if we were to do that aggregate, we could see some value. Now, the challenge for manufacturers becomes with those type of applications. If I printed 1,000 of them, I may not come back to you for a year or 2 years because I got to wait till I consume them, right?
Yeah.
And so contract manufacturers, I've had conversations with them where we set up relationships, we build all of the infrastructure in place to do this efficiently, and then we don't come with any parts right away. Well, it's because of the nature of the industry, right? We're not doing volume, we're not doing repeat parts, and as we consume them, then we'll come back and purchase more. But in many instances, I'm going to print one, and if you make it last for 10 years, hey, that's great. I may be willing to pay a little more for it, but that means I'm not going to come back to you with the same part within a short period of time. Mm. Now, what will happen is I'll come back with other parts, as long as I can get past that initial hurdle. And so there's multiple hurdles to that, right? One of them is, I'd like to say the technology really isn't the hurdle anymore. The hurdle is with people, right? And in many instances, you've got established relationships with service providers, with manufacturers, and it's hard to overcome that, that comfort level. I know this technology. I know this person. They come to my they come to my facility and they bring donuts or something, and so I've got a personal relationship with them too. This notion of, well, I'm dealing with a contract manufacturer who I don't know, who I don't have the same level of personal relationship with, and so there's a cultural paradigm shift that has to happen in order to drive adoption. And some of that, you drive some of that by awareness, right? You get out and you talk to people. You give them a basic understanding of what are we talking about with this technology. The greatest value we had is we would have contract manufacturers. We would host these workshops, or we went around the world. We visited like 20 different facilities, talked to hundreds of engineers and specialists and frontline maintenance personnel. And we would have the contract manufacturers come and bring parts. We want you to come and bring something real, because once we were able to get some of those parts into the hands of these engineers and these specialists, it went from, oh, that's great, I see it on a slide, to, well, I can hold this thing. It's, especially metallic components. I had a discussion with an engineer early on in this process where he was like, well, can I put it into water service? Can I put it in hydrocarbons? It's not going to dissolve. It's not going to come apart at the layer line. So some of that is just knowledge, right? Understanding the process and technology, and then touching it. Like, let me see what it looks like. Let me feel it. And then test data is helpful too. So when you talk to a contract manufacturer that's done thousands of builds, that increases people's confidence in the capability of those manufacturers, right?
For sure. And so as we kind of wrap up your kind of time at Exxon, maybe kind of where are you going next? Where do you see kind of your additive manufacturing journey continuing?
So I see two potential roads that I may take. I like to make stuff, right? I'm a maker by heart. Manufacturing components, there's nothing like, I've got to the stage where I can put something on my FDM printers, and I'm not going to fiddle with it and watch it the entire time. But when I get something off it at the end, and I'm able to, and I've got dozens of parts that are laying around my garage with me right now that are in some stage of assembly. I like making stuff. So I think that the direct application of the technology is valuable. I had actually started a pilot program at ExxonMobil where I had deployed bamboo lab printers into our engineering spaces. So people, with the notion of, hey, let's just have people make stuff. Let's show them they can do it. Let's make it simple. Let's put the tools in place. And in the beginning, let's let them manufacture whatever they want so they become comfortable with the technology, because it quickly goes from, well, I'm making a tchotchke to go on my desk to, well, I have a problem to solve, and I know that this tool can do it. So I'd like to continue on in that space. We did some early work looking at pump components. We worked with some OEMs to try and move the conversation along around some long lead time critical components that could potentially be added to manufacturing. And so seeing that continue to grow, that would be valuable to me. The other thing that I'm looking at is potentially doing some consulting, right? So there's an opportunity to look across the qualification processes and look for similarities between oil and gas, aviation, the automotive industry, and start looking for synergy. So when API went out and developed API 20S, which is the metallic standard for additively manufactured components in oil and gas, they leveraged a lot of the learnings from aerospace. They leveraged academia. They really reached out and used other people to help build out the standard. And so I think we can lower the cost of qualification if we can start looking for where we're similar. So what that means is a manufacturer that is in the contract manufacturing space that's servicing aerospace, and servicing they're servicing aerospace, oil and gas, automotive. They don't have to each time go back and be requalified for a different standard, right? So looking for synergies, they exist. So how do we leverage those? I think that there's also an opportunity to help small and mid-sized companies adopt the technology. Unfortunately, they can't have a John Barnes, and there's two of us. There's the John Barnes from the Barnes Group, and there's me. They can't have us full-time on their staff, right? They don't have a team that can help them adopt the technology. But what they can do is they can leverage, consulting partners to learn how to utilize the technology, to provide awareness to their employees, to look for applications, and really work towards utilizing technology. Because at the end of the day, what do I want? I want to see people using the technology. That was the whole reason I pushed ExxonMobil to become more involved in it. Is there's the technology is awesome, right? I'm not trying to overplay it or overhype it. but there are opportunities to deliver things today that 10 years ago I would have thought were not possible. Some of the things I'm seeing coming out of the maker communities, man, they're phenomenal. You see this rapid innovation mindset. I'm going to sit down and I'm going to develop a product. I'm going to iterate rapidly through it because I have a piece of equipment that will let me not only do design for this, but turn out physical parts so I can test and I can iterate rapidly. And that is a huge advantage over just a couple of years ago. I had this notion in the beginning when I got my first 3D printer that people talked about these showing up in everybody's house, and my grandma would have one, and I thought my grandmother could never run this thing. But that whole concept, I think, has changed, right? As systems become more polished, as they become more integrated, the potential for some of the people that are using these machines, it is really kind of enlightening. I know of in Houston, there's actually a sewing company that uses the printers in their sewing storefront to produce parts. And so there is this opportunity that's kind of exploding, especially with the low-cost printers. And I think the challenge in the U.S. is how do we encourage some of the local machine manufacturers to produce the same quality of machines, the same type of integration? And they need to look beyond the machines, right? The machines are just, it's as things are, right? Once I purchase the light bulb, if it lasts forever, I'm not going to buy any more light bulbs. Uh-huh. So we need to look at those add-on services. Once I've produced a component with it, what are the material options? The material options for polymer printers are somewhat limited today, right? What other materials can I use? How can I get into the engineering materials that I may have some interest in? How can I introduce new composites, new capabilities? Things that 10 years ago were very costly and difficult to reach. If those are easily within reach, then I saw those little bamboo lab printers popping up like weeds. Right, I would talk to some of our sites.
Yeah, I've got one behind me.
I've got one behind me too, and I've got competitors too. And these machines are so much more capable than even the MakerBots were. 10 years ago, you spend a lot less time working on the printer than you do making stuff. But still, I think the word of caution for your listeners is these are manufacturing machines. They're not printers. They will require care and feeding. They will break, but you learn so much by going in and getting into how these machines work, how they operate. There's that. That's really what got me really deeply embedded in this, was taking them apart, breaking them. Right, I broke that Mindel Max that I built so many times, including that melted hot end. But I learned a tremendous amount by doing that. I learned a tremendous amount by going into the firmware and tweaking things and learning how they really operated. It really gave me kind of a grounding of, well, what can these do? And then as I branched out and I looked into some of the newer or the other technologies, right, the metallic technologies, they are different, but they're all based on a similar premise, right? They're based on similar concepts that can be they can't be directly translated from one to the other, but support in polymer parts. Well, I've got support in metal parts for a different reason. That leads us to, I'm looking for the way I can print this without supports, right? So I really started moving that. So where do I see myself going? I think the best place I provide value is evangelizing the technology and then helping individuals and companies understand how to use it. Right? It's within reach, without a doubt. It's just you need to apply it.
Awesome. And so one last final question, more of a fun one. So we collect our guests' book recommendations for a holiday season book list from 3Degrees Discussions podcast. So do you have any additions you'd like to add to that list?
So, like I said, my original background after my pre-engineering work was in IT. And so I looked pretty heavily, and I'm still involved in some of those communities. And one podcast I like to listen to is called the Darknet Diaries. And I think it's a very enlightening view into cybersecurity. And right, even in the additive space, right? What does cybersecurity mean? And what are some of the vectors and the way that people are exploiting vulnerabilities, even in our own homes? And how might we overcome those challenges, right? Things are rarely as secure as we think they are. It really kind of gives you a view into how should I protect my own data? Why do people want it? What's its value? And so I would highly recommend it. It's fairly technical, but it really gives a good view into, in many instances, the presenter, he talks to reformed cyber criminals about, how do they get involved with the technology? What are some of the things that they did? what did it mean, overall. And so I would highly recommend that particular podcast.
Awesome. Well, thanks so much for your time today, John, and look forward to seeing you around the industry and continue all your good work.
Thanks so much, Mike, and I appreciate you taking time to chat with me.